A messenger from beyond. In October 2017, the cosmos delivered a mystery. Astronomers using the Pan-STARRS 1 telescope in Hawaii detected a strange object streaking across the sky. At first, it looked like just another asteroid, one of countless chunks of rock drifting through the solar system. But this one was different. Its speed was far too great, its trajectory too unusual. Within days, scientists realized they were witnessing something historic, the first confirmed interstellar visitor ever detected. The object was given a Hawaiian name, Oumuamua, meaning a messenger from afar arriving first. And true to its name, it became a messenger that challenged everything we thought we knew about celestial bodies. Unlike planets, asteroids, or comets formed in our solar system, Oumuamua had traveled across interstellar space for perhaps millions of years before its chance encounter with Earth. It was a relic from another star system, a cosmic drifter passing through. The journey through the solar system. Oumuamua entered our solar system at a blistering inbound speed of 26 km per second, fast enough to prove it wasn't bound to the sun's gravity. Its path was hyperbolic, not elliptical like the orbits of planets, meaning it was simply passing through, never to return. On September 9, 2017, before it was even discovered, it had already made its closest approach to the Sun, coming closer than Mercury. As it swung past, its velocity increased dramatically, reaching 87 km per second, fast enough to escape the solar system forever. But what puzzled astronomers wasn't just its speed, but its silence. Comets that pass this close to the Sun usually flare up, releasing bright tails of gas and dust. Oumuamua remained cold, dry, and eerily quiet. It gave off no visible jets, no coma, and no debris trail. A shape unlike any other. Then came the question of its shape. Based on how its brightness changed as it tumbled, scientists estimated it to be up to 800 meters long but only 80 meters wide. That's a 10-to-1 aspect ratio, unlike any known asteroid or comet. Some likened it to a giant cigar. Others suggested a flattened, pancake-like shard. It rotated every 7.3 hours, creating dramatic swings in brightness, far greater than any object previously studied. This wasn't the smooth spin of a planet or a familiar asteroid. It was more like a tumbling baton, turning with strange rhythm as it sped away. The puzzling acceleration. The real shock came as Oumuamua left the Sun behind. Instead of slowing down as gravity predicted, it accelerated, ever so slightly, but enough to be measured. Something was pushing it, but what? The usual explanation for such acceleration is outgassing, gas escaping from melting ice, acting like thrusters. Yet telescopes, including Hubble, detected no such emissions. The object appeared completely inert. Some theories suggested that it might have been shedding invisible hydrogen or nitrogen gas, which wouldn't leave a visible trace. But models showed such materials wouldn't survive long journeys through space. The most intriguing explanation was solar radiation pressure, the idea that sunlight itself was nudging Oumuamua along. For this to work, the object would have to be incredibly thin, perhaps less than a millimeter thick, with a huge surface area. That would make it less like a rock and more like a light sail, something that could, in principle, be engineered. Alien hypothesis versus natural oddities. This is where the debate began to heat up. Some scientists, most famously Avi Loeb of Harvard, proposed that Oumuamua might be a fragment of alien technology, perhaps a probe, a derelict craft, or even a discarded sail drifting between stars. Its thinness and unexplained acceleration fit that model better than most natural explanations. Others strongly disagreed, arguing that extraordinary claims require extraordinary evidence. Instead, they proposed natural, though still unusual, possibilities: a nitrogen iceberg chipped off a Pluto-like planet, a hydrogen iceberg, invisible when venting gas, or an exotic shard of rock. Unlike each idea had flaws. Hydrogen ice evaporates too quickly to survive long journeys. Nitrogen blocks would have eroded long before reaching us. And no known natural process creates objects with such extreme shapes and thinness. Michio Kaku and the limits of physics. The mystery soon captured the public imagination. Physicist Michio Kaku suggested that Oumuamua forced us to consider possibilities beyond our current physics. To be clear, the object did not travel faster than light. Its maximum speed was still under 90 km per second, far below Einstein's cosmic speed limit. But Kaku argued that its anomalies, its shape, its silence, and its acceleration, should make us open to ideas such as advanced propulsion, warp drives, or technologies we cannot yet conceive. Kaku's point wasn't that Oumuamua was alien, but that it reminded us of how much we don't know. The universe, he emphasized, is stranger than we imagine, and our current models may only scratch the surface. The watch for new visitors. Oumuamua vanished into the darkness, forever out of reach. But it left behind a new scientific frontier, the study of interstellar objects. Astronomers know more are coming. In fact, in 2019, a second interstellar object, Comet 2I Borisov, was discovered. Unlike Oumuamua, Borisov looked like a typical comet, with a bright coma and tail, confirming that interstellar debris does indeed pass through our solar system. And the search is intensifying. The Vera C. Rubin Observatory in Chile, with its massive 8.4-meter mirror and 3.2 gigapixel camera, is expected to find dozens of interstellar visitors in the coming decade. By scanning the sky every few nights, it will create a time-lapse record of cosmic motion, spotting faint and fast-moving objects. Already in 2025, the Rubin Observatory detected a massive interstellar comet, far larger and brighter than Oumuamua, proof that more cosmic messengers are on their way. Project Lyra and the dream of interception. Astronomers don't want the next Oumuamua to escape. That's why ambitious concepts like Project Lyra have emerged. The idea is to launch a spacecraft capable of intercepting future interstellar visitors. Using gravity assists from planets like Jupiter, nuclear propulsion, or even laser-powered sails, such a mission could chase down these fast-moving objects and study them up close. Imagine a probe sampling the chemistry of an interstellar fragment, scanning its structure, and sending back data on its origins. We could learn what distant star systems are made of, whether they share the same chemistry as ours, and perhaps even whether organic molecules, the seeds of life, are common across the galaxy. Beyond curiosity, interstellar objects are more than curiosities. They are messengers. Each one carries information about worlds we cannot yet reach. Their composition might reveal alien geology, different isotopes, or even exotic materials unknown to Earth. If organic molecules are discovered, it could support the idea of panspermia, that life's building blocks travel across the stars, seeding planets. Even their trajectories teach us about galactic dynamics, how often objects are flung from star systems, and how many of them wander the galaxy. Humanity's interstellar moment. Oumuamua may have been natural. It may have been artificial. We may never know for certain. But what's undeniable is that it changed the way we see the universe. For the first time, humanity realized that the space between stars is not empty. It is alive with travelers, fragments, messengers, perhaps even relics of civilizations. The question is not whether more will come. They will. The question is, will we be ready? Do we remain passive observers, watching them vanish into the night? Or do we prepare to meet them, to intercept, to study, and perhaps one day, to answer the question that has haunted us for centuries: are we alone? Oumuamua came in silence, left without warning, and gave no clear answers. But its legacy is profound. It was the first knock on the cosmic door. And one day, when the next messenger arrives, we may finally have the courage and the tools to open it.